I am very fine. Yes, I am very fine.
So you are traveling or completely?
No, traveling very limited because I am in Italy now, in my country home. I am doing some work from home, but I also had some vacation in the month of August. Italians always have some vacation, so I went to the mountains for 10 days.
Oh, that's good.
Yes.
You are lucky that you have done a vacation.
Yes.
So Bara was the main person who suggested to go for something called Bridge Discussion Forum, and we started. So the very first Bridge Discussion Forum PDF was last third week of the last month on the topic of bridge failures during construction. So basically, we are taking up topics which are not very much talked about, not very frequently talked about, or people may shy away talking about those things. So we took that. It was quite popular. Lots and lots of people joined us. And this time we took another issue when we asked the people last time, the attendees last time, that bridge and expansion joints on seismic devices. Because again, there's a lot which is not known properly to the people. For that matter, even I do not know everything all that well. So we needed an expert. And I'm very thankful to Dr. Agustino Marioni from Italy, who agreed to sort of enlighten us. Now, basic idea of this discussion forum is as if it's all of it is a panel discussion. When I say panel discussion, it is not only the panelists who speak, everybody speaks. Panelists are there to receive what you say, and they are there to discuss with you. Sometimes we may even, although normally you will put your question in the question answer box, but sometimes we may unmute you so that you can have a direct discussion like in a physical event. And Dr. Marioni is, of course, quite an expert. So let me first introduce the panelists today, which is important. One of our panelists out of three is engineer Atul Bhobe. So Ruhi, may I ask you to put his slide in front?
Yes.
Engineer Atul Damodar Bhobe is a B Civil and MSc Civil Engineering from Michigan, US. He is managing director of TPF Engineering Private Limited, and he's on the board of directors of TPF Group, a multidisciplinary consultancy group with more than 4,500 personnel and operating in over 45 countries, almost like 100 people per country, with a turnover of almost 2,000 crores of rupees. His expertise includes structural design and engineering of buildings, bridges, flyovers, highways, skywalks, railway tracks, institutional structures, sewage system, water system. He is also an expert in design of cable stayed bridges, steel structure bridges, and using software for design. He has published and presented over 100 papers in national and international seminars. Engineer Bhobe is recipient of Institution of Engineers India National Design Award in Pre-Stressed Concrete 2006. Of course, I received this award 7 years later. Of course, this was by INGI. Basically, I got it from IEI. He is life member of Indian Roads Congress, Association of Consulting Civil Engineers, IABSE, American Society of Civil Engineer, USA, Indian Institution of Bridge Engineers. Of course, he's there. He's a member of the executive committee as well. Institution of Engineers India, Indian Concrete Institute, Consulting Engineers Association of India. So I think nothing is left now. All the disciplines are covered. All the professional bodies are covered. He'll not have any loose pockets to cover any further. Everything is covered. The other panelist we have with us is Dr. Harshavardhan Subbarao. He holds a master degree from University of Michigan and PhD from Imperial College London. Okay. He has been involved with number of landmark projects such as Signature Cable Stayed Bridge in Delhi. We were also involved with them on the same project, Signature Bridge. 4.6 kilometer rail cum road bridge at Patna. That must be a large project. Bridge number 20 on Jammu Dhabur rail link with a very large span, I remember about 150 odd meters. Metros, viaducts, elevated roads, arch and extra dose bridges, underpasses, etc. In fact, the two of us have been quite associated in many projects. He is a vice president and member of Technical Committee of International Association of Bridge and Structural Engineering, IABSE Zurich, and chair of its Bulletin Edit Board, member of Highway Research Board of India, serves on several committees of IRC, BIS, FIB, and various international and national bodies. He is also vice president of IABSE, and as a result, he is the senior most in India for IABSE. And he has over 35 years of experience and a number of papers and bridge projects to his credit. So we have a right person, and I know he is a person who is involved a lot in bridges, bridge bearings, expansion joints, and seismic aspects. Our one of the panelists is again a very learned person, engineer V.N. Hegde. Presently, the chief executive officer of Stoop Consultants and former executive director of Gammon. He's a senior professional with a rich experience of over 3.5 decades in construction sector in the area of design and management, technical management, site management, project management, contract management of highways, bridges, energy structures like chimney and cooling towers, environmental, marine, and hydraulic structures. Now, he has a good amalgamation, I know him personally so very well, of construction and design. He's also into code committees where the designers are mostly the members, and he's also been into construction for such a long time. And maybe he was associated with the design team of the contractor, that's Gammon. And Gammon, in fact, MD of Gammon, and the person who really brought Gammon up to a high level was Dr. Harshavardhan Subbarao's father, Dr. T.N. Subbarao. Now, Mr. Hegde again, he is recipient of around 9 national recognitions in addition to an international prize of various institutions, IRC, ICI, NDRF, IBC, and IABSE. He has more than 140 publications to his credit, and he's a member of various IRC and BIS code committees. He's also a member of TG 10.1 of Federation International du Beton, FIB, if you know, which is a special task group working on FIB Model Code 2020. That's a code to deal with concrete properties. Apart from being on technical board of ICI and academic board of SPCE, that is Sardar Patel College of Engineering, he is also a fellow of Indian National Academy of Engineers, FNAE, sorry. So with all these credits, I take in fact pleasure in spelling out the CVs of these three learned gentlemen. Now, if I go to the speaker, Dr. Agustino Marioni, at the outset, let me tell you, he is a very humble, very nice, but extremely knowledgeable person, extremely knowledgeable. He's available to you, he's available to us whenever we want, and in one line request, he responds that, yes, I am there and I'll be there. Dr. Agustino Marioni graduated in civil engineering in year 1966 at Politecno di Milano, that's Italian. He got a specialization in bridge design with Professor Franco Levi in Turin until 1974. He founded the company Elga. You must have heard of the Elga long back in Italy on the expansion joint bearings, etc. in 1969 and has been its chairman until 2012. Elga has been pioneer in the field of structural bearings and anti-seismic devices for more than 50 years. He has been the chairman of European Commission for the structural bearings standard EN 1337. That's a very important European code, mind you. He has been member of the European Commission for the anti-seismic devices standard, that is 15129 is another very important code, and we are taking help of this code for preparing Indian code for Indian conditions for anti-seismic devices. Dr. Marioni is currently the chairman of Hyron International. Now, in a way from Alga, he just have this another company, new company, which is Hiron International, using all the same experience which he would have gained over 30, 40, 50 years. It's a highly specialized company in structural devices with main office in Taiwan and branches in China and Italy. So Italy connection still remains, mind you. Now, friends, what we have done for discussion forum is, as I said, this is more of a panel discussion, or more of a discussion and discussion and discussion, just to give a beginning to the topic, or to give an overview of the topic. We have about half an hour odd presentation by Dr. Agustino Marioni. And after that, all of us, including the people you see on the screen, or maybe you don't see some of them on the screen, they will all be available for an open discussion with you. And we have kept the discussion time more than the lecture time. So now may I request Dr. Agustino Marioni to please come forward and make his so-called presentation.
Okay.
More like a workshop, more
And
like a discussion.
Can
Yeah, thank
you
you.
see my screen, or okay?
Not as yet. We see you rather.
Can you see my?
Ruhi, just check up.
Eh?
Not as yet.
Marioni sir, you'll have to present your screen.
One moment, because I don't see now the option.
So
No,
you have
Dr.
to
Marioni.
click share screen.
Okay, and now just one.
Dr. Marioni, first you open your screen in the background, then you maximize. Yes, something is.
Sir,
Oh,
I'll present. So you'll see a bar like this. So you have to just click here.
So for
I'll just.
do you see the icon of share screen at the bottom, the green colored one?
yes, but
I'll
Okay.
stop it. Now you can share.
Yeah, now you can share. So first you put
Okay.
your presentation on the screen. Then you bring. Yes, is there.
okay.
Just put it on the
Sorry
screen.
for my.
No problem.
Okay,
No problem.
now it's clear. Okay, so the theme is bearing expansion joints and anti-seismic devices, and I put some summary that was distributed. There are many items. I'm not sure I will treat all of them, because normally all these matters I use it to make lessons in the Politecnico di Milano for the duration of 8 hours, and here we have only maybe 1 hour. So sometime I will go very quickly, and you can ask me after the conversation everything. So we start with the bearings, and with the bearings I like to make reference to the definition of the bearings given in the European standard. So what is very important, that bearings are devices allowing rotation for sure. So there is no bearing if there is no rotation allowed between the component of the structure. And the bearings transfer forces if they are fixed bearings in all direction, or can allow displacement in one direction or in two direction if they are unidirectional or multidirectional bearings. So the two fundamental functions of the bearings are rotation and displacement. And so we see now that there are only 3 physical principles available to perform this function. The rolling, the elastic deformation, and the sliding. There are no other system to accommodate this, to make this function. So the rolling has been the first principle utilized since mid 1800, as soon as the industry developed steel products. And the rotation and the sliding were obtained with a roller, but the roller had also some important problems. Stress concentration, because all the loads were concentrated in one line. Difficult to get multidirectional bearings. The rotation and the displacement can only be perpendicular. Very big dimension, very high cost, and problems with low temperature, brittleness. So here I found an example, maybe this is not the first, but is dated 1870 in the United States, in Ohio, and is a steel bridge with roller bearings, but there were many in this century. Here, in example, this is a recent project of roller bearing in Germany. Just to have an idea, for a bearing capacity of 37,000 kilonewton, the mass of the bearing was 28 tons. So I put this number in evidence to show the evolution of the bearings. We had 0.76 kilogram of steel for every kilonewton of bearing capacity. The second concept utilized for the bearings was the elastic deformation. This was used as soon as the process of the rubber vulcanization has been discovered by an American person, Goodyear, in the mid 800s. So the rubber is still used a lot in the bearings, and for elastomeric bearings and also for pot bearings, with some problem. For the elastomeric bearing, you have limited displacement capability and behavior depending on environmental conditions. So cold or warm weather influence the stiffness of the rubber, and the rubber has aging problem, and so a limited life, limited, not very limited, at least 60 years. And the last principle used was the sliding. This has been used since 1960, based on the use of PTFE first. PTFE is Teflon, still used. The use of Teflon is due to a German professor, Professor Leonhard, that was very famous, that I met, I knew personally. And this made a revolution in the field of the bearings, allowing to make bearings with no stress concentration, very easy to get multidirectional bearings, and low cost. So here you have an example of sliding guided pot bearings. I think is one of the most used bearings in the world up to now, still used a lot. I don't describe this bearing because everybody will know, but this is a combination of the deformation capability of the rubber disc, and the sliding capacity of the PTFE. Here an example of the giant pot bearings that I designed and we manufactured in 1990 for the football stadium of Milano, and the bearing capacity 75,000 kilonewton. And you can see the mass capacity decreased to 0.151 kilogram of steel per kilonewton of bearing capacity. But the real revolution has been with the spherical bearings, and especially with the introduction of new sliding material, because the PTFE that has been used and still used has some problem, because the size of the structure increased always, and the PTFE became in some cases not sufficient for this problem. Limited strength, so compressive strength capacity, limited resistance to the high temperature, and low wear resistance. The wear we will see when the bearing slides the PTFE can accommodate only 10,000 meters of displacement. And this is not sufficient in some railway project, and especially in metro lines, where the flexibility of the bridges is high and the displacement due to the flexural bending is very high. So these are the limits of the PTFE given by the European standard, and compressive strength 90 megapascal, but these reduce a lot with high temperature, and wear resistance 10,000 meters. The PTFE is not anymore good when for very long span bridges, special suspension bridge, where the displacement due to the wind action is very, very high. Railway bridges and metro lines, this due to the frequency of the trains and to the flexural bending that induce a lot of displacement. Or when the temperature field is exceeded, and this can happen in Arabic Peninsula and some Indian regions when the 38 degrees are exceeded. And this temperature is for sure exceeded when the sliding material is used in anti-seismic bearings. So for instance, in a long suspension bridge, this is the Messina bridge that has never been built, designed in all details, but never built. So we studied the bearing for this bridge, but the sliding path of the bearings due to the wind vibrations exceeded 2,000 meters per year. So the PTFE absolutely cannot be used. So we developed other materials, and for instance, for this bridge in Portugal. And so this just to give you an idea about how the weight of the bridge has been reduced. Sorry. So the mass divided the bearing capacity has reduced to 0.05. And you can see here in this table the evolution of the bridge. Roller bearing 760 mass per 1,000 kilonewton bearing capacity. Pot bearings 150, spherical bearing with special sliding material 50. The reduction of mass of weight, what we call wrongly call weight of steel, reduced a lot, and this reflected the reduction in cost of the bearings. So the sliding material, and especially the new generation sliding material, are very important in this field. The sliding material are tested with a special machine that here represented. And I put here in this table the comparison between the main properties of the PTFE and the last generation sliding material. So HI3 and HIM is the sliding material we developed, and ultra high molecular weight polyethylene is another material that is included in some India standard. Maybe now they remove it because it was patented, but just to make a comparison, now the compressive strength from the 90 megapascal of PTFE has doubled or more than double for the new generation material. And the heat resistance also is very much increased. And the wear resistance is amplified by a factor of 5 or more with approximately the same friction coefficient. And so the most suitable bearing to take advantage from the new sliding material and to take advantage of the reduction of dimension and the reduction of cost is the spherical bearing. And for this reason, now the spherical bearing is so widely used in many projects. Here is an example of fixed bearings. Fixed bearings, so it means can allow 3 degrees of freedom of rotation and transfer 3 forces, the vertical one and the 2 horizontal one. One example big example of application of spherical bearing is the Bangkok monorail, where nearly 8,000 spherical bearings are currently under manufacturing and supply. The Bangkok monorail is a metro system line, super elevated, and here are some pictures during the construction. Okay, now I give a few words on the expansion joints. And there are 3 main types of expansion joints. The modular joints that consist of a succession of watertight rubber profile, rubber seal, and steel beams supported by a cross beam. And here you see the detail of the fixation of, so not all the types are like this, but more or less all are similar. To get the waterproofing, the rubber profile is inserted by pressure in the steel profile, and the steel profile are rolled with appropriate shape to get the connection with the rubber profile. And here you see an example of expansion joint with around 600 millimeter displacement used in Italian motorway. Another kind of joint are the rubber mat joints. And these are made in rubber and steel and allow the displacement, the movement by shear deformation of the rubber. This kind of joint are very economical and are very much used in the world. You see here some example of application in Italy. And the finger joint. The finger joint is a very was the first joint developed for important bridges since the 19th century. It's very simple and very robust. And the only disadvantage is the waterproofing is not perfect, so require a drainage underneath. And I summarized in this table the main advantages and disadvantages of the different types. So the finger type has absolutely a low cost and a high durability, but has limited waterproofing, and the water drainage, if not well maintained in the time, maybe after 10 years is broken. And if the waterproofing is broken, the water flows under the bridge, and normally under the joint there is the bearings that are severely corroded. And the finger joint cannot allow transversal movement. The rubber mat joint has the advantage of low cost, easy installation. The transversal movement are allowed, so this is very suitable if the bridge is base isolated and can move in both directions. So the rubber mat joint is an easy, low cost and efficient solution. The disadvantage is the durability is less than 30 years normally, and is not recommended in cold climate because the rubber became very hard under, I don't know, -10 or -20. The modular joint is very commonly used in India and provide a perfect waterproofing, a high durability, but is expensive. And the transversal movement can be allowed, but increasing a lot the cost and the complication of the joint. So this is all for the joint. I don't want to, and I pass to the third topic of the speech, that is the base isolation. And I hope to show you that the base isolation is an easy technique and can be applied with great advantages to increase the safety of the structure with normally there is not an extra cost to be paid with the base isolation, but a reduction of cost. So to understand the base isolation, we have to refer to the acceleration spectrum of the structure. The acceleration response spectrum is given by the relevant seismic codes and provide to the designer all the useful information allowing designing the structure. In the response spectrum, in particular, are given the information about the intensity of the earthquake and the effect of the soil properties. So here you have the response spectra given by the European standard, but after I will show you the Indian standard, but just to see the shape of the response spectra. So the response spectra are giving the acceleration transferred to the structure in function of the period of the structure. And this diagram reflects different damping of the structure from 2%, the highest diagram, to 30%. Looking at the shape of the response spectra is immediately understood what shall be the strategy for reducing the action of the earthquake on the structure. So increasing period and increasing damping. So it's very simple. You have to perform these two tasks. Now we see how you can reach these two tasks. So the anti-seismic strategies are very simple. Increase the natural period, increase the damping. Here you see you have the Indian situation. I took this from IS 1893. I don't know if it is the most updated, but the concept will not vary, even if the... so in India you have seismic zone second to, so 4 different types zone, and you have the acceleration spectra given for 3 types of soil, rock or high soil, medium or soft soil. And the anti-seismic devices available, we can divide in 3 main categories. So the base isolators that apply both strategies, increasing the period and increasing the damping. The dampers, they apply only one strategy, increasing the damping. And the dynamic connections, they do not modify the seismic action. They create supplementary links in case of dynamic actions like earthquake, breaking force of trains or wind. So let's see first the base isolators. The base isolators are defined in the European standard as the devices or the combination of devices providing 4 functions. Support the weight of the structure, provide lateral displacement capability, provide recentering capability, dissipate energy. So there is no base isolators without recentering capability. This is very important. And there is no base isolation without relative displacement. And base isolator should also dissipate energy to reduce the acceleration. So they will increase the natural period of the structure and increase the damping. How can an isolator increase the natural period of the structure. So the isolator has his own natural period and shall be placed between the structure and the foundation or the piers. And placing the isolator, the structure will be forced to swing according to the natural period of the isolators. So there are two kinds of isolators, and they are harmonic oscillators. So one type of isolator realizes the concept of the spring and the system of mass spring. And so the period given to the structure is 2p for the square root of the mass divided the stiffness of the spring. We will see which are the isolators that provide a spring, that are the elastomeric isolators. Or the isolator can be like a pendulum and will shift the period according to the expression 2p. L is the length of the pendulum or the radius divided g, the gravity constant. Now we will see the different isolator, how they work. And how the isolator can dissipate energy. There are three systems used. The friction, used in sliding pendulum isolator, the yield of metals in lead rubber bearings, and the viscosity of rubber, used in high damping rubber bearings. Dissipate energy means generate heat. And so this aspect is very important and need special attention and special test to verify the effect of the heat on the isolators. So there are three main types of isolator. The high damping rubber bearings, where the spring effect is given by the rubber elasticity, and the energy dissipation is given by the rubber viscosity. This kind of isolator has been invented, was not the first isolator invented, was invented in year 1985 by Professor Jim Kelly of the University of Berkeley in California. Here is the typical load deflection plot. So horizontal load, horizontal deflection. And you see that the diagram includes an area that means the device is dissipating energy, because the area is the displacement multiplied by a force. So it is an energy, it is a work. And the area of this diagram is defining what we call the equivalent viscous damping, that is given by the formula energy dissipated by cycle divided 2p for the stiffness for the displacement squared. The stiffness is, you cannot define by convention, the stiffness is the stiffness of the third cycle for rubber elements, because the rubber has special properties. The first cycle, for instance, gives a higher stiffness and has a phenomenon called scratching. But for this reason, we take conventionally the third cycle to define the stiffness. So the behavior of the high damping rubber bearing can be completely defined by two parameters only: the stiffness and the equivalent viscous damping. The second type of isolator is the lead rubber bearings. This was the first one invented in year 1974 by Professor Robinson from New Zealand. So the spring effect is given by the rubber elasticity again, and the energy dissipation is given by the yield of the lead core. I can say this has been the most used and is still the most used base isolator in the world. Used for building, for bridges, for any kind of construction. So here you see the load deflection plot in the left, the theoretical one, and in the right, the experimental one. And the behavior of this device can also be fully described by two parameters only: the rubber stiffness and the lead core. For the computation, we use the effective stiffness, Kf, not the rubber stiffness, and the Kd is function of the displacement d. So the behavior of these devices is not linear, but we will see how to make the computation in a very simple way. The third kind of isolator is the sliding pendulum. And the sliding pendulum can move according to the surface of a sphere with a certain radius. So it's supporting the weight of the structure, is providing lateral flexibility. Why? Because when it moves, all the structure is uplift, and so storing potential energy that is given back, going back to the initial position. The energy dissipation is provided by the friction of the sliding material. So, as a sliding pendulum is, I think, the most efficient isolator now. It's not very much used because maybe the designers are still reluctant. They don't know how to use. However, it's very simple. There are three kinds of sliding pendulum, with one sliding surface, with two sliding surface, with two sliding surface, and a center articulation. But from the cinematic point of view, they are all perfectly equivalent. And their behavior can be fully described by two parameters only: the radius, the equivalent radius, and the dynamic friction. And together with the displacement and the weight, we can define the stiffness, the period, and the damping of the structure. So now I will show, I have not the time to show how to use any kind of isolator, but I will just show for the sliding pendulum how to select the right pendulum. The function of the pendulum is defined by the radius, the dynamic friction, and we need to know the vertical load, the horizontal displacement, and the rotation. And first of all, we select the pendulum with one or two sliding surfaces. We see that the pendulum with one sliding surface is shifting the resultant only at the top. And the sliding pendulum with two sliding surface is shifting for half the value. So normally, for the bridges, we use the pendulum with one sliding surface. And for the buildings, to limit the eccentricity in the columns, we need the second. But this is not a mandatory rule. We can use it as we want. So what are the advantages of the pendulum in comparison with the rubber isolators? So the rubber isolator, in the rubber isolator, the period is a function of the mass and the stiffness, but both of them can vary. Instead, with the pendulum, the period is depending only on the radius and the gravity constant that cannot vary. For the rubber isolator, the stiffness is an intrinsic property of the rubber with the geometry and with the stiffness of the rubber. So, especially in building, the center of stiffness may not be coincident with the center of mass. With the bridges, normally is not a problem. For the pendulum, the stiffness is proportional to the mass, and so the center of stiffness and mass are always constant. But what is the most important? With the rubber isolator, the period shift has a limit given by the buckling, because to increase the period, you must reduce the stiffness. But you cannot reduce the stiffness too much, if not, the isolator will not be able to support the vertical load. So practically, you cannot increase the period up over 3.5 seconds. Instead, for the pendulum, you have not this limitation. To increase the period, you just increase the radius, and the only limit is the recentering capability. So practically, you can increase the period up to 6 seconds. However, must be said that the pendulum is not suitable if the period must be low. This can be the case when you want to reduce the displacement, for instance, nuclear power plants or metro lines where the rails are continuous and you don't want too much displacement in the beams. The pendulum has also a higher service life, is independent from the environmental condition, cold or heat, and is fire resistance. Normally, you perform the analysis, the seismic analysis of the structure with software like, I don't know, you use SAP 2000 or ETAB, and is very fine. But I always suggest to perform a preliminary computation with a simplified analysis. This allows you to select the right isolator in a very easy way. So with the high damping rubber bearings, you can perform the linear analysis. And with the lead rubber bearings or the pendulums, the linear iteration analysis. That is very easy. I will show now for the pendulum how it is performed. But if you want to go deeper in this, you must write me and I will help you. So to do the linear iteration analysis for a pendulum, we need to know the weight supported by the isolator, the equivalent radius. We can select by trial and error system, and also the dynamic friction. We need to know the spectrum, and we input a tentative displacement. And I use this table that is a very simple Excel table. And if you are interested, I can send you the software, but it's very simple because I put the expression of every formula. You can generate this Excel abacus in a very simple way. So you input the weight, you input the friction coefficient, you try 0.05 here. I tried because I tried 0.03, 0.04, 0.5, 0.6, and I found that this was the best with the given spectrum. You put a radius and you put a initial displacement guessed. I put 400 millimeter. Also, we have to put the acceleration spectrum. And for the Indian spectrum, that in the part we use for the base-related structure, the spectrum is represented by a parabolic function. You so the period is always if you put here SD1 is the acceleration. Is the acceleration for period 1 second. After, you can get the period with an easy computation. The period is equal to this value divided the acceleration is equal to this value divided the period. is a parabolic function. So you input in your Excel cells the mathematical definition of the stiffness, of the period, of the equivalent viscous damping with this formula. The damping coefficient, here I used the reduction of acceleration given by the European standard, but in the Indian code you have a slightly different formula that you can input. And after you get the acceleration, the displacement, and here you verify if your input displacement is equal to the output. If the output is equal, you are okay. But in this abacus, you iterate, you put the displacement of the first step of computation as input of the second, and so on until the output is equal or nearly equal to the input. At that time, you have defined your isolator. At this time, you can make your design and verify your design by ETAB or SAP 2000. So I always recommend this initial approach with the simplified analysis. Now some word about the hydraulic devices. All the hydraulic devices consist of a steel cylinder filled by silicon fluid, divided in two chambers by a piston. And the piston incorporates valves, allowing the silicon fluid to go from one chamber to the other according to the movement. So this is the scheme of a hydraulic device. And what is in pink color is the oil. And the movement, the hydraulic device has spherical hinges at both ends, connecting two parts of the structure. And when the structure moves due to the earthquake, the oil must flow from one part of the other. And the mathematical model of the hydraulic devices is shown by this formula, very simple formula. So the force is equal to a constant multiply the velocity at an exponent alpha. With the valve, we can modify the exponent, and normally the exponent used in the construction in the anti-seismic devices varies between 2 and 0. Here is the diagrams of the force in function of the velocity. And with exponent 2, we have a parabolic diagram. And the exponent 2 is the exponent that gives automatically a device without valves, where the oil flows through a hole. This is the law of the movement, turbulent movement according to so-called Reynolds. This is parabolic. We see that this behavior dissipates a lower part of energy. So to have what we call the viscous damper, we want to modify the exponent and to bring the exponent near to 0. So you see in green, you have the exponent 001, and in red, the exponent 015. And so normally we use as viscous damper these exponents. And we use for lockup devices the exponent 2. The difference in behavior is lockup devices just create supplementary connection of the structure, and viscous damper dissipate a lot of energy. You see the difference in energy dissipated here in this diagram, where the same devices, we have here the diagram of the force, not in function of the velocity, but in function of the displacement under a certain movement law. So in red, we have the result for exponent equal 2, so the lockup devices. And in black, we have the device, the viscous damper, that dissipate more energy. So physically, okay, this I already explained. Physically, the most simple shock transmission unit, the oil flow through the space between the piston and the cylinder. And for the viscous damper, this is more complex. For this reason, they cost more money. The oil must flow through valves inside the piston. The computation of the structure incorporating these kind of devices is not so simple as for the base isolators, and require time history analysis. Yes, I show some example we supplied for Bangladesh. These are very big size, 12,000 kilonewton capacity and a big displacement. We supplied for the Taiwan high-speed railways. This was for an application not for earthquake, but this is a common problem for the railways lines, where in the continuous, normally the beams for high-speed rail are simply supported, but in the station there are continuous beams for some reason. And the problem is when the train breaks, the designer don't want all the horizontal load to go on one pier. So the lockup device is used to share the horizontal load between many piers, between the fixed and the movable bearings as well. So here's some example of application in Portugal, in Romania. The most important application we recently did was the Kerch Strait Bridge connecting Crimea, the peninsula of Crimea, to Russia, and supply more than 700 devices.
Dr. Marioni, may I ask you how much time? Is about 2-3 minutes fine to find out?
Maybe 5 minutes. I try to,
because we want to give more time to the audience to,
okay,
clarify their minds.
a few words on quality assurance and testing. Yes, maybe 5 minutes.
Sure.
So in India we work with SICO, and so all the products for India are manufactured in India, and we have ISO certification, of course, and all the certificate. And for many products, we even if not required in India everywhere, but we have CE marking that is represent a higher level quality assurance. Okay, this is an example of the material certification. All raw material are tested according to the quality control plan. And about the test, according to the European standard, there are two kinds of tests, but now I think India is implementing their standard for anti-seismic devices and getting inspiration from the European standard. So we have type testing to be performed on each type of device and factory production control. So here in this table, but this presentation, I sent the PDF to Mr. Vinay Gupta, and so can be shared to all the participants, can be given if you lose something because I go very fast. here are the different tests required by the European standard, divided in type tests. So the type tests normally are more complete, and the factory production control only covers some aspect. And for instance, for hydraulic devices, the factory production control is required only for 5% of the pieces, and also for the viscous damper. For the rubber devices is required the factory production control for 20% of the pieces. This is different from the American standard that require 100% of pieces to be tested. Sometime in India is applied the ASHTO, requiring 100%, sometimes the European standard. So this make a big difference in cost and delivery time. Okay, for the pendulum, the European standard require 5%, the American standard 100% again. It is very important for seismic device to perform dynamic tests, because without the dynamic test, you cannot see the dynamic coefficient of friction, and you cannot see the effect of the heat on your device. Here you see a dynamic test with registration of the heat inside of the lead rubber bearings. Dynamic tests require very complex and very expensive machine. And I hope in India, very soon, some university will be equipped with that. So the dynamic test is essential to put in evidence the right dynamic coefficient and to verify the effect of the temperature, because in the pendulum, especially, the heat generated is very, very high. In some tests, we reached in the pendulum 190 degrees. So we must, here is a test performed in California, San Diego, and in pink, the pink line is the temperature in the pendulum. Okay, I go very fast here, some application, Padma Bridge, hospitals, high damping rubber bearings, metro lines, and I pass to the conclusion. So bearings has been utilized in bridges since early 1800. Since then, the technology has been subjected to a considerable evolution, and modern bridges utilizes very high performance sliding material that can grant long life, resistant to extreme environmental conditions. Railway bridges require special care, especially on the wearing resistance. And sorry, this was the same. And seismic isolation is the most effective system to protect a structure from the earthquake. Sliding pendulum are the most efficient and the most cost performance effective. Base isolation greatly simplify the design, and the best solution greatly simplify the design because you design your structure in linear field, not in non-linear field. The best solution shall always be evaluated case by case. Quality assurance is of primary importance, and a good standard is essential. But I think India is now issuing very, very good standard in this field. So thank you for your attention. Sorry if I went maybe over the time, but the item are are a lot, and it's very, very difficult to concentrate in short time. Thank you for your attention. And now I am at your disposal for any question.
Dr. Marioni, I must compliment that you have spoken so slowly in terms of speed that I am sure everybody would have grasped whatever was to be understood. The kind of stable presentation you had, slow, loud enough, at the same time deep enough. There was mathematics, there were pictures, there were small short videos, and so on and so forth. So my sincere thanks to you. Ruhi or Deepika, can you please put off this presentation? Oh, I think Dr. Marioni, you can put off the screen, the share screen part.
Yes.
Yes. So for the knowledge of the audience, let me tell you that we have prepared a code in the IRC Indian Roads Congress, which is IRC SP 114. And this
Okay.
code does cover many of these aspects Dr. Mariani has explained today in terms of how to take care of seismic aspect. In fact, the code IRC 6 makes a direct reference to this IRC SP 114, and one should make use of it. Apart from that, let me tell you that immediately after this code, SP 114, and of course, whatever knowledge people have gained, this height damping, not height damping, but rubber as a damper has been utilized for two large projects in Delhi, aggregating to about 20 kilometers of viaduct with a width of 35 meters. And they have heavily reduced the earthquake forces and also reduced or rather finished off the demand of special confinement. Because once you have taken rubber, R value, response reduction factor is 1. So there's no ductility and all that required or special confinement required. It has already been used. STUs that you
Okay.
discuss, shock transmission units, have also been used in number of bridges in India. Dampers, I'm not very sure whether hydraulic dampers have been used to my knowledge, but maybe there are some projects where they've been used. I think a panelist will also throw light on it. Only regarding testing, I want to tell everybody, Dr. Marioni and others, if it's a special device whose numbers are few, it is fine to test 100%. But in some contract in India, for the regular bearings, they have defined 100% testing. And now because of the testing, the project is getting delayed because there is no facility available to do so much of test.
I know.
Okay, so you know India more than Italy perhaps. So there are problems like, so we have to be practical that what is doable only we should specify in our tenders, in our contracts. It is very important. So with these words, I'll request our panelist, Dr. Harshavardhan Subbarao, to at least throw some light on the presentation and give his remarks. He has a huge experience and he's a CMD of a Customer Consultancy Private Limited.
No,
Please.
Vinay, thanks so much. It's nobody can touch a patch on Agustino. He's just in a different league, and he's been involved with the development of the Eurocode with Tobias Jordan and all my other friends, and so obviously he knows the subject upside down. The three aspects touched today are on bearings, expansion joints, and seismic devices. They all have to work on a structure where movement is an issue. They all have to work in conjunction with each other. It cannot be that you have an expansion joint which cannot take the increased period displacement that may be enabled by a damper or a sliding device that will increase maybe the time period and therefore the displacement at an expansion joint. That expansion joint then has to be designed to cater for that additional displacement or the requirements that may be coming on that joint. So they actually are three of a same family. These three things belong in one family, and that's why the topic today contains all three of them together. Coming to the topics that were discussed, of course, the two codes are the 1337, the bearing code, the European bearing code 1337, and the 15129, which is the anti-seismic devices code. Recently, I've been referring to both of them quite a lot. I'll come to that next, but in India, the testing facility, as you said, Vinay, that we need to build up that testing facility to qualify the bearings. The factory production control lacking, and the type testing is invariably done abroad. Now, two projects on which I'm involved at the moment, with one in which there has been a collapse and where the bearings were 6% damping type bearings, high damping rubber bearings, and another which is now ongoing and is under construction, for which we have just approved the bearings, initially designed for 26% damping, now down to 18% damping, and through our iterative work, it has come down to 18% damping, and those are LRBs. The LRBs are probably being used for the first time in India on Sahibganj, this project called Sahibganj. And these are on the extensive approaches of nearly 11 kilometers, which are there on that project, which is spine beam strut type of structure. But there we have managed, because of the seismic requirement, we have been able to use initially designed by a competitor of Hirun for 26% damping. Then we tempered it down to 18% damping. And this all had to tie with the fact that at the expansion joints of a 4-span module or so, there would be too much displacement. And then we devised a so-called pop-up bearings, which you might have known, Agustino, that, you know, these kind of pop-up bearings that are there, which pop up and come back down during the agitation of the earthquake when the displacement demand is too high, and the expansion joints have to cater for that. Yes, the Q and the K are both K effective and Q are the main issues for that lead rubber bearing. And we will now see what we will do with the testing. So the testing for that facility of the LRB does not exist in India. And we might have to do the type testing elsewhere so they're performance-based. You know, the K and the Q are both performance-based issues which are specified, and that's how the design is done. But to prove that that performance is achievable, we have to do the testing, without which we cannot actually qualify those bearings for use. So though the design is done, considering a performance requirement, to prove that that performance is met has to be done by testing. This is one issue. The FPC will, of course, the manufacturer of the bearing gives us FPC, but the type testing still needs to be done. The other issue, and that facility does not exist in India, which, as you said, someone should actually pick up and use, because we are using increasingly anti-seismic devices on many major structures in elevated roads and major structures. I was involved also with Puri Saab for some period of time on the bridge in Bangladesh, Paira Bridge, where we use STUs, and Puri Saab, I hope, will speak about that. Yes, we used STUs on that bridge, a very major bridge with 267-meter spans, 8-lane, 6-lane type structure, huge concrete structure, so huge mass, and in a seismic demand zone, in a high seismic zone. And there we've actually used STUs in the design. How you incorporate that in the analysis as a rigid link and pick up the forces are all aspects which I think the engineers should learn about and learn. Your favor is for pendulum bearings, Agustino. You are very clearly in favor of, but they are less in use here. I have occasioned upon high damping rubber bearings, and I have occasioned upon now for the first time an LRB bearing, which I'm involved with. But very rarely do we use proper friction pendulum bearings on projects. I wonder why. The other point on bearings is something that we should all debate. Is there is the Watson bearing, which is a disc bearing, and that is very, very, very much used in the US and other countries in Latin America and elsewhere, but simply not used in India at all, maybe except one project. So the disc bearing is, something which is not pondered and is not contemplated. And other members of the panel I know who have been involved with those projects will throw a larger light. Why a disc bearing or a Watson bearing is not used, I'm not sure why, because simply we don't have a code for it. I think there is room for them also to enter and to be seen how that can be incorporated. Of course, you talked about the STUs, you talked about the viscous dampers, which dissipate more energy. The issues are again of maintenance. All these devices have a maintenance regime and a life of their own, because if it's hydraulics, there's always a life. If it's a type of rubber, there's always a life because of ozonation, because of deterioration, environmental degradation, there's always a life. If it is high heat, like your ultra high molecular weight sliding surface, which is far, far superior to Teflon, it also has a life based upon the heat and based upon the ambient temperatures in India. So I want to caution in a way, and I want to throw some more light on this point for Agustino to debate and the other members of the panel to debate these issues. Thanks. That's all I have to say, actually. The expansion joints, I want to tell you that on this structure, we are using a so-called pop-up expansion joint, which literally pops up. The modules actually pop up in the earthquake and they come back down. And that's because of the high displacement requirement that's coming to these expansion joints. So, they have to be used in tandem. One cannot be without the other. So Maybe Agustino, you want to talk a little bit more about these things, about period and damping, and how these are all together in these devices.
Thank you, Dr. Subbarao, for your, good and enlightening words. Oh, you have anything more to say? Okay.
Nothing.
But we wanted the discussion to be a fairly low level and more receivable to the participants that we have, and I think we are going very high.
Okay.
Panelists are supposed to enlighten the people and not.
Let's put it the other way around. Let's put it the other way around. Let's put it the other way around. That there is a need today because of the large structures that are being built and the large river crossings that are necessitated, and the elevated corridors in cities, and wherein maybe in seismic zones, may not be in seismic zones, but high seismic zones. There is a need, I would say, to look at incorporating all these methods of damping or period enhancement into our structures so that we can develop what is below a bearing as an elastic structure without a demand for any plastic confinement, without a demand for looking at it in a plastic way at all, and making it very, very simple with R equals 1, as it were. In our codal terms, it will be R equals 1. We're a force-based code, not a displacement-based code, our code. So that is different, Agustino, from where you come from. We are a force-based, we are not a displacement-based, and we're not a performance-based. So the Euro codes then have to be tempered with the fact that we are force-based. So given that, I would say we are on the path to using these devices because it simplifies. What then happens is that there is no difference like a fixed pier, free pier, and an expansion joint pier. Typically, if you have a 3-span module or a 4-span module, you have one fixed pier at which you arrest all the seismic forces or the braking forces. And you have free piers, and then you have the expansion joints after 3 or 4 spans. Now, that is not necessarily required anymore when you go, all piers are the same. All foundations then can be made the same. That the modularity of the structure, the shuttering, and that the huge cost savings are there when you adopt these devices in simplifying the structure. This is the most important contribution these devices make.
Yes.
In making simple structure and making all, there is nothing like a fixed pier or a free pier or an expansion joint pier. Yes, there will be an expansion, but all are designed same.
Okay, so I think I'll thank you right now, but of course for the moment, and you'll have more interaction with the participants, which is very important. I'll request our conglomerate of design and construction and CEO Stoop Consultants, Engineer V.N. Hegde. Mr. Hegde sir, are you around? Yes. So, like to have your expert views on this.
Yeah, I don't have much to add. Harsha starts the discussion. I don't think he will leave anything else for the others to discuss, and he has covered most of the, the information which has to be given to the participant. But I would like to look forward to the discussions from the participants because it's supposed to be a big forum rather than.
Absolutely.
But, talking about Dr. Marioni's presentation, and it's an excellent presentation. He started with the rocker and roller bearing, which used to be used earlier days, how the evolution of the bearings as well as the expansion joint took place. And I like the way he explained the principles behind the bearings as well as the expansion joint, starting with how the displacement as well as the rotation is the function of the bearing and how it is enabled. I think it's a very good point to start with, where the elastic elastomeric bearings are used by virtue of the deformation, the rotation as well as the sliding or the translation takes place, whereas in case of other bearings, it's normally not because of the deformation, it's because of actual rotation and the actual sliding. And also I like the way he explains this base isolation system and emphasizing on the fact that the linear analysis, how it has to be used, simplified linear analysis has to be used, if at all, if it has to be, if we have to go for the computer-based analysis, either by the ETABS as well as any other software. I think it's a sort of a guidance which has been given to the participant. And I also have the experience of using this shock transmission units in Brahmaputra Bridge in Guwahati. It was a 1.5 kilometer bridge. Normally 1.5 kilometers single girder bridge. When I say expansion joint to expansion joint, the length space between the two expansion joints is around 1.5 kilometer. If you want to achieve that kind of spacing between the expansion joint, all of you are aware the expansion joint is a source of weakness. Any joint for that matter is a source of weakness. And also when your riding surfaces gets disturbed by the expansion joints, so you will have to use as less number of expansion joints as possible. That is possible by way of use of the STUs. I would like, exploit the presence of Dr. Marioni here in the sense, especially when you have an STUs, like the shock transmission units, say for example, it is subjected to the earthquake condition, and for it to get locked, it has to have an initial movement of, I don't know, very small movement it has to have, right? And if it has to have an initial movement, all this, the shock transmission unit may not get locked at the same time. If it is not getting locked at the same time, one of the piers might be subjected to that extensive horizontal force. I would like to have a clarification from Dr. Marioni. That's one clarification. And
Yes.
also, I would like to seek a sort of enlightenment of the needle beam expansion joint, which has been used nowadays extensively in case of the extradose bridges. I think you're not touched upon that. That's a bone of contention as far as we engineers are concerned, whether to use this needle beam expansion joint, especially for the long span bridges, at the end of the cantilever, at the mid span, to meet the two cantilevers, needle beam expansion joint or the bearing you call it, whether it can be used and what is your experience of using that. These two clarification, whenever Vinay Gupta permits Dr. Mariano, I would like Dr. Mariano to give. One is under the earthquake conditions, there are multiple spans. If the STUs are used, for the STUs to get locked, it has to have an initial movement, certain movement. If all the STUs don't have the same locking period, one of the piers will be taking the highest forces. How really, in reality, really what happens? These two clarifications I need from Dr. Mariano.
Venkat, they're not connected. Venkat, they're not connected to a common manifold pump in any way. Though they're hydraulic devices, they're not connected to a common manifold pump.
Yes.
And if there's a delay, it will all vary because the period will be different for the height of the pier. No? Everything will vary. So that Marioni will speak about that point and clarify a good point.
No. I think you didn't understand the question. The question is, there is a silicon fluid inside the piston, right?
Yes, but they will work differently
just a minute,
because of the period.
There is an orifice in that. Basically, that the orifice is very small. The viscous silicon fluid has to pass from one
side to the other chamber.
Say, for example, you have fitted the STUs on the 5 piers. How do you ensure all
5 are at the same time?
Gets locked.
Mobilized at the same time.
Locked at the same time. Otherwise, one of the piers will be taking more. That is not the condition which you are.
That's what I said. They're not connected to a common manifold.
May I suggest, let Dr. Marioni explain, but Dr. Marioni, please, the time allocated is only 2 minutes. Because we also want to hear the audience.
I think it's not possible to warranty that every peer get the FTU is locked at the same time. One important aspect that nobody consider is that the viscous fluid is not uncompressible. But if you have a working pressure, say, of 60 megapascal, the compression of the silicone oil is 4%. So if the stroke of your device, say, is 500 millimeter, 4% means 20 millimeter. Is something very, very important. So you will never have the lockup devices blocking at the same time.
Never possible.
So when it doesn't lock at the same time,
No.
one of the piers will be getting the higher forces than when you are.
But the pier will bend, and so we'll try to equalize the forces with all the piers, but the forces will never be the same. So you should use sliding pendulum isolator. With this, you have the same force for every pier.
So I'm advocating for your cause of pendulum isolator here.
Yes.
No, well, I will tell you,
them,
this
and you will
isolation
you will
pendulum.
save a lot of money and a lot of maintenance, because
Yeah.
look, lockup devices are hydraulic devices, and all the manufacturer, I don't say me, no, all the manufacturer, they say, oh, the lockup devices are no maintenance forever. I am very friend of Professor Jim Kelly, that is one of the columns of the base isolation worldwide. Now he's very old, but he's still alive in Berkeley. He was entitled by the California Transportation to make an analysis of all the viscous dampers supplied in the California. And after he told me very confidentially, look, I see many brands, but only one type of viscous damper don't leak oil. I say, which one? That is empty.
So some light moments.
It's a joke,
Okay.
but we must joke.
But for everyone's information, I know Dr. Marioni also may be knowing that there is a building in Gurgaon, that is Delhi, and there is around Delhi NCR, and one in Noida, which I have seen. They are using friction pendulum dampers
yes, we
as
supply
isolators below the building.
Yes,
And when you can use it below the building, you can as well use it below the bridges.
Yes,
And
yes.
I think awakening is coming now, because earlier we didn't have a code. Now we have this code IRC SP114, which
We-
gives you permission to use. So I'm sure slowly people will start getting
we
used to
supplied
using it.
the friction pendulum in
Right.
India for two projects. One was the Gurgaon building in New Delhi,
Right.
and the other was the office of our friend, that is Mr. Jain. Yes.
And Dr. Professor Vasant Matsagar of IIT Delhi was also instrumental in designing it.
Yes.
Right.
So with the pendulum, you can have a better base isolation, because you can shift the period to 5 seconds, say, and have a damping of 30%. So if
Right.
you compare with other systems,
That's right.
and the
So-
pendulum will not cost more. It costs less.
So we have said this in the code SP114.
Okay.
Vinay,
Yes.
can you throw some light on this needle beam articulation? I think that is
Okay,
important.
Dr. Marioni, please. You are the best person. I'm not an expert on needle beam isolator or whatever the expansion joint. Dr. Marioni, any idea?
What about?
I think that has to be explained perhaps. You see, in suppose there is a long cantilever bridge.
Yes.
In between the two cantilever arms, sometimes we'll have to provide the articulation, right?
Yes.
Now, in some cases, many of the cases, we are providing the steel girders, which is fitted with the bearings.
Yes.
That
Yes,
we
I
call
know.
it as a needle beam expansion joint. Needle beam sort of expansion joint we provide it. Do you have any experience on that?
Needle beam expansion joint. No. You normally put a steel beam with bearings that can resist the vertical load, the shear.
Same thing.
Yes.
Identically the same thing. What he's talking about, what the needle, exactly what you're talking about. How is it effective or not effective?
But the joint can be normal joint. No need to be a special joint.
Okay.
Okay, I think we can have this debate sometime later. For the moment, let me inform all the audience that all these types of bearings, seismic devices, expansion joints, whatever we heard just now, they're available apart from other manufacturers. Also, there is one in Ghaziabad, that's north of India, around Delhi, in a factory which is Seco Hairun, I'm sorry, and they're available. and Dr. Marioni also in a way connected to this manufacturing.
Yes,
And he
yes.
has been kind enough to give us this presentation, which I request the IB team to please pass on to all the audience, all the attendees, because that will be very useful to have it in their archive and they can make use of it. So they have been kind enough. Before we go to further panel discussions and further question answers, now the questions are increasing. I'm getting more and more burdened with the questions and feeling a bit of um, uh, bad about it. Just want to ask anybody from Hiron, who are our sponsors today, Seco Hiron, do we have any presentation to make by any chance which we had in our program about their facilities that are available for all of us to use in India or even abroad? So Dr. Marioni, Ms. Ashwini Gupta, Mr.
About
Ujjwal
no,
Gupta,
I did not understand any presentation about what?
about Hiron.
Yes, yes, we have, of course, presentation about Hiron.
We had a slot for the presentation and I forgot to request.
Ah,
So if you have any something like 5 to 7 minutes, let us play that. At
but
least
now
people will know that what we have
I
in
will
India.
not prepare this, and so.
Okay. So do one thing, Dr. Marioni, if you can also provide this short presentation, we'll give that also to the participants.
I can, yes, I have the presentation, but now maybe it's very long.
No. We don't want very long right now. We can't afford it.
Because if I had noticed before, I could prepare, I don't know, 5 minutes.
I see. Well, we do have, what I was trying to say, that we are definitely thankful to this team, Seco Hirun, who have been kind enough to not only sponsor the event, because that is required, otherwise IIB cannot function any very much, and also make a presentation, and more than that, also providing the presentation and giving a permission to share it with all the participants.
So, yes. The presentation I made today, I sent you the PDF, and
Right.
you can give to everyone.
Yes, I read your email. Thank you so much.
Also, I think everybody can go to the website of Hiran and of SICO, and
yes,
in the website of Hiran there are a lot of information that I had not the time to give about the main job we performed, but also like a manual for selecting the right type of bearing and expansion joint or anti-seismic devices. For instance, the bearings, where to put the fixed bearing in a continuous bridge, in the middle, in one abutment. All these information are given in, so many information are given in our website. And in the last slide, you have the address of website of Iran and SICO.
Right, thank you. So friends, we have our one very important person, former Director General, Ministry of Transport and Highways, Engineer S.K. Puri. He is presently convener and chairman of some of the IRC code committees. So may I request Engineer Puri to please say a few words about this topic?
In fact, I don't think I have to add too much on this, because it was a very nice presentation, and Engineer Hegde and Dr. Ashwardhan, they have also pointed out. I would only like to point out one thing, that all these devices and all the technologies which are coming, we really find some kind of issues which Engineer Vinay Gupta has also said regarding the testing part in India, that if we want to adopt that, although the manufacturers are ready and they are prepared to provide us those things, but issue of the testing becomes, so that is what we all have to think about it. And maybe we are in people like Mr. Marioni or others could help assist to either, you know, we obviously a country like India where so much construction work is going on. So we need to have those testing facilities in-house in India itself. So
Yes.
I think that is one issue I would like to only say. What Dr. Ashwardhan said about the Paira Bridge in Bangladesh, which obviously we had been working, and it was not we were working. In fact, Dr. Ashwardhan were advising on that bridge. I was only a learner on that. 200-meter extra dose bridge. See, the bearings there, I doubt that I can really throw any light on it because a Chinese contractor is there. They came out with their own design, and it was really a very, very complicated design. And then it had to be, you know, proof checked from one of the British consultants. And we are adopting, we have adopted that. That bridge is almost complete in a month or two. It will be completed successfully. So I think that is beyond my personal capabilities to say anything on those bearings. Is very complicated. It's basically the vertical bearings in that pier cap, how it has been put. So you see this online, it may not be possible to say anything. So that's what I would like to contribute. That is the testing part which is needed, whether it is whatever devices, new devices, anything which is coming internationally. If we have to use them, we need testing facilities. Thank you very much.
Yes.
Thank you, Burisa. We have a representation from railways. We have engineer R.K. Goel. So we want to, sir, we like to hear from you as to what you feel in the railways about these bearings and various kinds and seismic devices and so on and so forth. I know that you have been using a lot of mechanical bearings.
Yes.
Please.
First of all, let me congratulate Mr. Agustino Marioni for a wonderful presentation. It is my pleasure to listen to him for the second time. He had come to Bombay some 3-4 years ago, and we have listened to him on the same topic. But this time he has definitely upgraded his presentation to a very high level. He has covered the design aspects also, how the different design requirements are to be taken care of, and also by trial and error method, how the table is to be used. All those things he has covered. That is definitely a very, very high level design aspect. Now, I'm convinced with his conclusion that for taking care of the seismic loads, one should go for the sliding pendulum bearings. Actually, when we go for some new technology, the first requirement is the awareness. And the second requirement comes in the form of guidelines, design guidelines or design aid, and then the maintenance instructions. And particularly in railways, when we go for a new thing, when we think of providing a new technology, we first think about how it will be maintained over a long period of time during the service life, you can say. So that is a big hindrance because most of the people, they are supplying the product, but they are not supplying us the technology. With the result, our people feel a bit apprehensive about use of that technology in a big way. So on an experimental basis, we start with experimental basis. Then gradually, when we develop confidence over its use and its maintenance behavior, then we go for a big application, you can say. But fortunately, about these seismic devices, shock transmission unit, and then this, particularly this LRB, etc., sufficient awareness has already been there, because in RDSO some 10 years back, we worked on guidelines for seismic design of railway bridges, where covered all these methods of dealing with the seismic forces. So now my point is, if we are really going for, if we want to go for mass application of all these things, first of all, we have to see why we are not able to develop the testing facilities. If these machines which are required for testing, if they are very costly, then what is the cost and why they cannot be provided in some of the institutes like IITs. We have got a department of earthquake engineering in IIT Roorkee and also somewhere in Hyderabad also probably. So we have to think of removing all those impediments which are hindering the mass application of all these new technologies. Like STU, I am of the view that STU is basically, it should not be used in the initial design of the bridges, where proper bearing should be designed to take care of the loads that are expected to come. STU can be a device which can be used for the retrofitting needs of the existing bridges if they are lacking in taking care of the seismic forces, or because of the increased longitudinal forces of the railway traffic particularly. So, of course, all these things are required to be discussed a lot again and again so that people remove their doubts and they get confidence about how they are to be used. So rest of the other things, I think we should give more time to the questioners, as you have rightly said. So I will stop here in brief. That is all from my side. Thank you.
I think, Mr. Goel, this testing in a separate laboratory is more of a chicken and egg story. Manufacturers do have laboratories and they can test. Unless we specify in the contracts, the owners, the clients, or you people, and say your railways or what, that you have to test it in an external independent laboratory. Somebody will not be inclined to do it. At the same time, unless there's a laboratory, you cannot specify. So, you know, that issue is there. I now request academician, Mr. Professor Surya Prakash. He is from IIT Hyderabad. Quite highly knowledgeable person. Sir, if you have any further comments on this, it will be very useful for us.
I think I completely agree with the suggestions made by Engineer S.K. Puri, and as well as you know, that it's high time that we should set up this facility for testing. And like you also correctly pointed out that unless it is specified for testing by a third-party agency, then you know the veracity of the testing may not be taken very seriously, because the manufacturer anyway will give certificate that everything is fine. So that is one of those things. And the fundamental principles of all these, you know, STUs as well as LRBs is very clearly known. It's just that, you know, the confidence of using it, I think it should be built by these kind of, you know, seminars and training programs, and also the standard guideline that the IRC SP, I think 111 that you're talking about. If it is there and it's more awareness is created, I think it's time that people will start using it. I think I could totally agree. I think we should set up a good testing facility for, you know, on, I think, you know, the IIT. In fact, we are also trying to augment our experimental facilities. But I think the one that needs for these kind of devices is highly sophisticated ones, because you need to put vertical load as well as apply horizontal in a displacement control mode. So it's quite involved and also very large capacity. So I think definitely, I think it's the need of the hour. I think fantastic presentation from Agustino Marioni. I think I really enjoyed it. Thank you.
Thank you, Professor. Before we have interaction with the attendees, our Director General, Engineer DG Devte, who got stuck up somewhere in some engagement, has reached us now and he's with us. So, Mr. Devte, if you are available and if you are on the connection, then would you like to say a few things? Mr. DG Devte?
Can you listen to me?
Yes, absolutely.
Firstly, I'm sorry for joining late. I was traveling from Mumbai VT to my place, but I got stuck up. Sorry for joining late. I joined when the presentation was already over, but I had attended his presentation in Mumbai if I remember correctly, about 3 years back in one of the hotel. We had a presentation from him. I heard him at that time. So, and afterwards, after getting the reactions from our experts, I find that presentation was really excellent and enjoyable. So instead of my giving the comments, now I will request all our other participants to get involved and listen to them. So thank you very much.
Thank you, sir. Thank you. Thank you so much. So I'll just run through a few questions, which of course all the panelists can also see. One of the, of course, obvious thing is request Mr. Pavan Kumar. Sir, it is requested to share handouts as it is very vital, basic, fundamental, can be used for reference. I fully agree with you. It is definitely vital, basic, and is needed. And therefore, the presentation request Ruhi or Deepika, please supply it to all the attendees. Ms. S.K. Dhawan writes, what is the life of rubber isolator? I think Dr. Marioni is the right person to answer.
Yes, shall I answer?
Yes, please.
So the rubber, normally we say the rubber lasts 60 years. Why we say this? Because the aging of the rubber is increasing the stiffness of the rubber, because the rubber with the time, due to some oxidation reaction, will become harder. So normally is accepted that a bearing can increase the stiffness, an isolator can increase the stiffness of 15%, 1/5. This is not a mandatory rule, but is a general rule. Increasing the stiffness 15% imply to increase to reduce the natural period of the structure, if it is base isolated, by 7%. And so the designer should take care of this factor when doing the design of the bridge. After 60 years, it does not mean that the bearings must be replaced in any way. But okay, this is a pure reference number. So I would say 60 years is the useful life of a rubber bearing.
So take from here is that if the rubber is made properly, with the good quality, with absolutely the ingredients that we specify in our codes, in our MORTH specifications, it can give a life as much as 60 years. It's a good life, fantastic life. And of course, ozonization should be less. It gets affected adversely by the ozones and carbon monoxide. Given the condition, okay, if not 60, it may give you 20, 30 years, which itself is also a very good life for elastomeric, which we never think it is as much. So thank you, Dr. Marioni. At least you're given correct answer. I mean,
60 years is the
say.
life of a bearings made according to the relevant standard. For instance, the European standard. A bad rubber can last 6 months or less.
Right.
A bad rubber.
Can be even tomorrow. And I have seen a structure where during the erection of the structure itself, the bearings had to be replaced. And then the replacement was done. Even they had to be removed and new ones placed in a few months within the construction period.
Yes.
So 2 replacements.
According to the standard, you have to test for ozone resistance and for heat. You accelerate the aging by the heat.
Right.
Okay, if you do this, 60 years is okay. If you don't,
of course, ozone is not in our control, but yes, ozone resistance we should check. Make sure the ingredients are proper. Carbon monoxide, we are reducing day by day by all these controls of emissions, etc. But still, it is there.
Yes.
No doubt. Another pertinent question.
Vinay, the point to add, which Agustino made, is that the stiffness changes with time. So if you are expecting a structure to be 100 years as a bridge, 100 years design life, 120 years design life of the structure, then at 50 or 60, the stiffness has drastically changed by about 15 to 20%. So that affects the time period. So the earthquake is not going to change. The zone is not going to change. The incidence of that earthquake will never change. So if you're using it for a damping situation, we want that you cater for both the current day situation at which the stiffness is as you define, stiffness of the pier plus stiffness of the bearing in series, all that in your analysis. And also the other case where in future time, we degrade the stiffness by 15 to 20% and bracket the problem and design for that eventuality also. So the flexibility of the pier may be actually enhanced or reduced depending upon the future tweak. So that is a very important clue for our design.
Yes, we can debate this and maybe make a change accordingly in our standards.
Yeah.
Mr. Rajiv Ahuja is asking Dr. Marioni, is that what are the EN and ASTO codes and standards for the design of LRB, that is lead rubber bearing, and high damping rubber bearing, HDRB, and FRPB.
Friction pendulum.
Yeah.
Sorry, the question is both standard.
Well, which is the European or and or ASTO standard?
Yes, both standard are suitable to design.
I think he wants a code number, standard number.
Yeah, it's EN 1337 and 15129.
Yes, so Mr. Ahuja, please make a note of it if you are there. And Dr. Marioni,
So
anything
European
you said?
standard for is 15129.
15129. You said that in the presentation.
And the American standard, either you use the ASTO standard for the design of basis-related bridges. Yes, for bridges you use definitely this, because there is another standard in the United States that is the ACI SEI that is mainly used for buildings.
I see.
But for bridges you use the ASTO. If you want the exact, I can send the email later, or let me see if I can open my. One moment. ASTO. The ASTO. ASTO guide specification for seismic isolation design. Guide specification for seismic isolation design of ASTO.
Yes.
This is
there a number to this or just a title?
Just the title, and the last version I have, but maybe there is a more recent version, is 2010.
Okay.
So it's guide to seismic.
You can find it even in the web. Maybe you don't need to buy. You can find it in the web.
Okay. Okay. So another question to Dr. Marioni, more relevant to you, I must say. How much Mr. Gaurav Ghosh is asking, how much difference between the static and dynamic friction exists for the sliding pendulum bearings?
A lot. So
that's not a very good word to hear.
No, it's a lot, and depends on the type of sliding material you are using, because some polymers has a friction coefficient increasing with the velocity, and some polymers decreasing. So you cannot say anything unless you make a dynamic test. Normally,
okay. So test is required to determine this percentage.
So,
but what type of percentage normally do you get, or you should be getting in what range?
So dynamic test can be the double.
Double, okay.
Or the half. So you cannot make a.
Right.
You cannot understand the behavior if you don't do a dynamic test at the velocity of the aircraft.
All right.
So,
all right.
This is essential.
Okay, there is information Mr. Nanda Dulal Dasgupta is providing to all of us. The information given is STU has been used long back in Vashi Bridge. Recently, NH project as Lumding, Assam, also STUs have been used, and those were tested in India. I mean, I would not know this, but if he's saying so, it should be correct. Then we have something from Sir
But
Praveen Nigam.
Vinay,
Yep,
STUs
yep.
have also been used, Puri Sahab, we have checked the whole design for that. STUs have also been used on 5-span continuous, 257 meters each span, 5-span continuous on Pyra Bridge. They're there on Pyra Bridge.
And Allahabad Bridge as well, which we designed.
Yeah, Allahabad Bridge,
bypass.
Exactly. Yeah, exactly. You got it there
Baseen
also.
Creek, yeah, of course, that he
Baseen,
mentioned. So
yeah.
there are cases, but he's talking about testing in India. That's what I wonder.
Yeah.
Okay, so next is by Mr. Praveen Nigam. Sir, in case of isolated foundation on rock, the recommended depth up to which it has to be placed is 1.5 meter. After placement of foundation, it would be filled with M15 grade concrete. This is recommended on RC 78. But my question is, if I fill the remaining portion with M15 grade of concrete, it would offer resistance to pier to move freely, and it will hamper the formation of hinges at junctions of pier and footing, which causes shift of location of the formation of hinge and create short column effect. So what is the opinion and suggestion? So we're talking about filling PCC concrete as per IRC 78 code, and effect of that on the hinge formation or shift of the hinge location. I would personally feel that yes, if you're filling concrete, there's a likelihood of shift of the, even though it is M15 concrete, but it is still strong enough to create the shift in the hinge location. So anybody would like to throw any ideas or any views on this from panelists?
No, I have no idea.
May I add in this?
Yes, Puri sir.
You see, now we are working on ministry specifications as a Bridges Apex committee. And now we are changing this M15. We are going to use only as a leveling course. Any other structural concrete, minimum M20. So that will be a change in all IRC codes as soon as these publications will come out, just to share with you. So M15 will be considered, M10 will be out of IRC nomenclature for all our this thing. So M15 will be the leveling course or blending concrete, and M20 will be the minimum structural concrete. Thank you.
Okay, right.
Vinay, this point is arising because this is the concrete. When you make an open foundation, around it you get a collar of concrete. We usually fill it with concrete, and so around the collar of the cutter, you know, the rock that is cut all around it, we densify it with this M15 or M20 grade concrete. The point really is that that concrete is not as stiff as the surrounding rock, or there is a disparity in the stiffness. So when there's an agitation and an earthquake, it is possible to have some slight movement at the foundation level. That is the question that is being asked. And if that foundation, if there's a sliding movement, for example, at foundation level, that will obviously affect the hinge formation because there's an imposed displacement at that level. So the issue is, yes, it is important. So what you should do where you have a situation like this, and which is also in the code, is to at least have 32 tor double bars at a frequent interval, drilled and grouted at least for 1.5 meters into the base rock to prevent such a sliding movement that may happen. So maybe this is the question that is being asked. I'm not sure if this is the right answer, because this is the annular concrete that is filled around the sort of open foundation, you know, to densify around the rock that is being cut out. So if that is the case, yes, you should ensure that the foundation is pretty well tight to the rock to get a behavior that you expect. If it moves at that level, even marginally, it will affect the whole behavior anyway. And definitely the hinge formation, and definitely it will affect the whole behavior. But in a way, if it moves, it can also dissipate earthquake force. A sliding action can also dissipate earthquake force. So I leave it. I don't have a clear answer, but these are my thoughts.
Certainly. Okay, so the next one is from Mr. Venugopal Buru Guptali. Can we use elastomeric bearings for more than 34 meter span? Hegde sahab, aap bataiye. You are designing elastomeric bearings, I'm sure, somewhere or the other down the line, but you have to unmute yourself.
Yeah. Can you hear me, Vinay?
Yes, absolutely.
Yeah, I'm traveling. That's the reason I'm asking it. Certainly, see, as long as the elastomeric bearing can be designed, why it cannot be used? Only thing is, the problem with the elastomeric bearing is, if your horizontal force is, like there's a relationship between the vertical force as well as the horizontal force from the shear modulus consideration. That has to be satisfied. Suppose if it's possible for you to satisfy, why not? Even if you can go up to even 50 meters span, it doesn't matter. But it has to be designable. That needs to be looked into by following the design codes. I think there is a relationship between the vertical force as well as the horizontal force at the time, and you will not be able to satisfy the shear modulus, like criteria which is there in the code. That's the problem there. Otherwise, it can be used.
Right, but I think the project which Dr. Harshavardhan Subbarao is investigating, it does have elastomeric bearings, which are very large size, 1.2 meter in diameter and 400 millimeters in height. And span is 40 meters. And there are 5 continuous spans, 40 meters each, 200 meter total. And they are using elastomeric bearings. So it can be used. There is no unilateral fact of limit of 34 meters.
But those are with
6%
damping. Vinay, those are specifically designed with
so they are used as dampers. They are damping. And since they're available, they are also dampers, but they're regular elastomer. There is nothing special. There is no high damping or anything. So you can use, there is no such limit of 34 meters.
Yeah, in fact, when you are using like normal elastomeric bearing, some of the properties of this, like of the base isolation, technique also you can take into consideration. Many of the times it happens, many of the times we do it. That is why even for the long span bridges, I think in the base isolation system, I think the principle is same. Actually, you'll have to satisfy this criteria of the deformability of that, whether it's within the limits or not.
Right. That's right.
Effective,
a question which is more sort of suited to consultants is here from Mr. Krishna Nandanam. The code should specify what kind of arrangement should be adopted to deal with seismic forces to make designers' life easier. Either to use LRB or STU or something else. That means we have only imparted knowledge that these are the things you can do. But how to choose what should be done? It's a very interesting question. I'm sure none of us can reply. So I don't want to reply to panelists also. It can be debated for a whole day and we'll have no answer.
So why are you limiting to the...
sorry.
Why are you limiting to the designer? Now the contracts, they allow the concessionaire and the EPC contractor to change the designs of each and every component in the project. So even at the field, they are permitted to make the changes.
Absolutely. So they're given that freedom, and with that freedom gives you the opportunity to use these devices.
Correct.
And the risk is then owned obviously by the concessionaire contractor who might do the job. The risk is fully transferred to them, but they have that option. Now, what are the benefits as a designer? Let's look at it this way. As I already said earlier, suppose you have a 3-span or a 4-span continuous module. In our traditional way with a pot PTFE bearing or so, we would design one of those bearing locations to be a fixed pier and to absorb all the seismic force. The others would be free piers, and the last 2 would be expansion piers at the peripheries. Now with these damping devices that we can do with the LRB and say the high damping rubber at least, we are able to simply design these piers all as same. There is nothing like a fixed pier, nothing. They're all identical, number one. And the whole thing is an elastic design with R equals 1. And there is no need then to have a different design with a plastic confinement reinforcement and looking at the, in fact, you will not invoke much of the IRC 114 code or guideline at all if you use these devices for the overcapacity moment and its design. So this is one of the huge advantages you get if you adopt these devices. The second you have is the STU. The Venkat raised a very important point as not being able to, the timing of all the STUs locking at the same time. But then the flexibilities of the pier will keep on changing based upon the height of the pier. Okay, you can never design all the STUs to lock at the same time. So you have a range of sort of delay, if you like. But within that time, since it's a quick shock, they all more or less will lock up within that very minimal time. And the forces will be shared amongst all the peers in an STU. After they lock, all the forces of the seismic event will be shared to all the peers. May not be in proportion, but definitely in proportion to some part of their flexibility and some part as a sudden action, because the flexibility may not be instantly mobilized, but in some part they will definitely be shared. So that is one way the STUs also add a benefit and are being used on many projects worldwide. The point now then is about how to use it in design. For example, an STU acts like a rigid link between the superstructure and the pier to which it is attached. It is a connection. And that connection acts as when you model, you would consider it as a rigid link delivering all those forces based upon the mass into that pier. So you would consider this to be shared. When you design an STU, the concept is that of bringing in a rigid link to replace the STU and to use that force demand to be shoved onto the pier in your design. The other hand is the LRB, the one I was talking about, the LRB bearing, which can be designed with up to 26% damping, a huge amount of damping, not the period only, the damping. Now, when that damping is so highly invoked, it has the concomitant effect of creating a high displacement at the expansion joints, which I spoke about. Then that demand has to be seen, whether it can be catered at the expansion joints of that module. And on the other hand, the K effective and the Q at which the actual shearing of the lead core actually happens, for which the sizing of that lead core is done, the diameter of the lead core especially, critical factor, is decided. That has to be seen in that light. What you want from the energy dissipation situation, the K effective, the slope of the K effective, and the Q, these are performance characteristics. I mean, one doesn't know a priori what you're going to get. It is a device. That device is not manufactured 100% something that you can guarantee. That's why the type testing comes into the factory production control guy. The factory guy will say whether it is company A, company B, or company C. Factory production control, perfect. I've done my factory testing, perfect. But the independent type testing that has to be done, say in the European lab with Genoa or say wherever you want to do these tests, then those tests have to be done. That testing facility has to be developed in India. That point has also been raised before. We do not have, so these LRB bearings which we are using on Saibganj will actually be tested elsewhere. We don't have that facility at the moment, Agustino. We'll probably be coming to Italy for that in India. That's another point that has been raised. One is the performance requirement. The other is to guarantee that performance is being met. I assumed 18% damage. Am I actually going to get it when I do that test? Am I going to get the K effective and the QED, and therefore the sizing of the bearing and the sizing of the lead core that I have, will that actually be met with through the performance? That can only be guaranteed by the type testing. It has to be proved by the type testing, if you like. So these are all important points I think the designers have to keep in mind, and where we have to keep in mind wonderful devices, but the fact that we need to be able to verify them through testing, that it is yet to catch up in India, in the Indian situation.
Okay.
And recentering, one important point Agustino spoke about is the aspect of recentering. Once the lead core is disturbed and sheared beyond its range, the QED is exceeded quite largely, it cannot be restored. Whereas a friction pendulum bearing is self-restoring. And there are various other types of devices, like for example, columns in New Zealand. They are using a number of such columns which can actually rock in place and recenter themselves. So the transfer is then down at the column base also. You can have devices which are different than what we have just spoken about now, which do the same function. So let us keep our minds open as engineers and designers to all this. Go ahead, Vinay. That's what I wanted to add.
Yes. Thank you. Now we have an intrusion that before people lose interest or something, I want to show you an event that is going to take place on the next Friday. Before we go to further questions, of course, we are not leaving them away. We have a very important and very interesting presentation on the next Friday. Of course, that is arranged by Engineer Ravindra Kumar Goyal. Is on what do you call it? Chenab Bridge, perhaps the highest bridge in the world, and fairly large span of 500 odd meters. And it will be presented by the constructors. So they will give you all the overview about. We had one presentation on this about a month or two ago, but people were not happy with that 2 hours or whatever. They wanted more. So we decided to continue, call it at number two as number two. Number one is over. And we will have it on 21st, if I'm not wrong, or 20th, that is Friday. Yeah. So please, all of you are requested to log in. And login means what is it? You have to register yourself and pay this nominal sum. And please join. Thank you so much. And now we are back to the questions. Yes, Ruhi, thank you. So the next, now we have a battery of questions from a very learned person, Dr. Lakshmi Parmeshwaran. She is from CRRI, or CSIR is called nowadays. And she is a part of the code making committee, which we have prepared as RCSP 114 together. And the questions I will read, and I hope we don't scratch our heads replying these questions. Seismic isolation bearings increase the natural period of the structure so that seismic demand is reduced. What happens to the time period of higher modes? So Dr. Marioni or anybody.
What happened to what?
What happens to the time periods of higher modes?
To the time period of...
Okay. Ruhi, can we unmute Dr. Lakshmi Parmeshwaran? Better
Yes,
that
sir.
she asks
Yes,
all the
sir.
three
Yeah.
questions that we have here on the screen. So, Dr. Lakshmi, you can unmute
Yes.
yourself and speak up.
Yeah. What I want to understand is that there is a shift in the time period when you are using this isolation bearing. But what will happen to the higher modes? Like whether that is what I want.
Okay, to the higher mode. Okay, I understand. But we normally refer to the first or second mode of vibration of the structure that normally maybe in a bridge deck represent 95% of the total mass. So the other modes are not so relevant for the base isolation, and we never considered them.
But this type of bearing can be used in cable stayed bridges also, where the frequency values are quite close. So in that case, what will happen?
No, I don't say they cannot be used, but they are not convenient. It's not convenient. The cable stayed bridge has a vibration totally different, and maybe transversally they have already a very, very long period. So it's not necessary to make a base isolation.
Thank you.
Maybe in the cable stay bridges or in the suspension bridges, instead of base isolation, you shall provide energy dissipation. That can be done by viscous dampers, but not base isolation, as you don't use base isolation in tall building. They are already sufficiently flexible. They have a natural period maybe or 4, 5, 6, 7 seconds. So to apply the base isolation make no sense.
But Dr. Marioni,
Yes.
Dr. Marioni, I'm happy to hear. But certainly, like in a cantilever bridges, in the extradose bridges, the base isolation can be used because it's a very rigid structure, right? It's not like cable stay bridges.
Oh, okay.
I'm talking about the extradose bridges.
Yes. In some cases, for very long bridges, you can reduce the vibration using other systems like the tuned mass damper.
Yes, TMDs.
Correct. I think I think we'll have to make a differentiate. We'll have to differentiate between the extradose as well as cable stay. I think extradose bridges, certainly we can use that, similar to what we are using in the cantilever bridges. That's a point I'm trying to make.
Maybe in the extra dosed bridge, yes, you can use the base isolation. You must see how much is the natural frequency of the bridge itself before you apply. And not always the base isolation is suitable. Not always.
Yes. Yes.
Correct. And also, the wind may be largely governing a more flexible structure, like a cable stay bridge. Many a times it is wind that is governing and not seismic.
Yes,
in
yes.
the design itself. Whereas a more rigid structure, because of its mass and increased stiffness in the deck, it may attract more seismic force. So then, yes, what Venkat is saying is very logical, that we may look at these kinds of devices also for a more rigid deck.
Yes,
like
but we have to make another meeting about the
separately. That's the point.
If we are going to spreading too much.
Dr. Lakshmi, any other question you have?
I have two more questions. One is about the dynamic friction coefficient, which you assume in the design and then get validated by the testing. But how do you ensure that during that 100 years that value is not going to change? And what maintenance requirements are there for the friction pendulum bearing?
The manufacturer can only say this.
No. We made also fatigue extended test to verify the variation of the friction with the wear and with the aging. So there are two factors. One is the aging, and we simulate accelerated aging, heating the device. So we heat at 80 degrees, we put in the oven for a certain time, so to simulate the aging. And the second, we verify the behavior of the friction with the long distance sliding. Of course, we cannot be perfect, because the only way is to wait 100 years and to see what is the friction after 100 years. But we can make some approximated value, approximated approach.
Okay, thank you.
Okay,
And
so
also,
yeah,
I would add one thing. When we make the computation, we always assume lower bound and upper bound friction, and we put a quite big variation of friction that is normally plus minus 20%, and this to allow to take care of any variation that could happen during the life of the bridge.
Dr. Lakshmi, if you remember, we have put this lower bound and upper bound in our code also.
Yes.
Okay, so next question is from Mr. or Ms. Sudarshan. In Europe, there is concept of limited ductility, considering R is equal to 1.5, which is not in Indian codes. If we consider R is equal to 1.5, whether the structure is to be considered in elastic state, or we need to consider the capacity design and ductility for these types of structures. Well, who can reply to this? At least I cannot.
Me? Yes. No. Normally we consider.
Once you used limited ductility, yeah.
We consider.
Yes, Dr. Marioni.
With the base isolation, we don't consider the ductility of the structure. We consider the factor R equal 1. So we consider the structure.
I think this question is slightly different, Dr. Marioni. Question is regular, normal, as if there's no base isolator, there's no other thing. Now you have a limited ductility, which is there in European codes, not in Indian codes so far. In those cases, when you use R is equal to 1.5, that's limited ductility, then structure is to be considered in elastic state, or we need to consider capacity design and ductility of these types of structures. Something must be there in Eurocode when a person is reading from there, but I am not particularly aware of it.
To answer this question, because unfortunately,
Vinay, let's look at this in a different way. Let's look at this in a different way.
Harsha, yes.
So suppose we have 6% damping. Suppose it was only 4% damping, and we could not knock off all the seismic force that is incident on that pier systems. And it's after all the mass of the deck, which is the mass, and the pendulum is that of the, I mean, as such, it's an inverted pendulum concept, and you've got your pier, which will have to absorb as a pendulum all the seismic force and dissipate by doing the work. Now, for that, we create our confinement, we give that plastic confinement, and we reduce the spacing of the stirrups, etc., in the plastic zone, right? And by the new 114, we designed for a so-called overcapacity moment, etc., at those plastic zones, etc. Now, coming to the point that is being raised is, suppose the provisions that you made by your devices are not going to absorb all the seismic force and are not going to dissipate all the seismic force, or the period is not so effective that it is such that it will kill all the seismic force and make you available for an R equals 1 given the sizing of your structure, should you then design the piers with some concept of ductility? This is another way I would look at it. Should we in any case provide it for a minimum concept of ductility at the suspect plastic hinge locations? Should we or should we not? And if so, is there some ratio? You know, if I design with more damping, then my seismic demand comes down on my pier. At one extreme, I don't need any plastic confinement at all. On the other hand, I may need, if I have somewhere between the two is my behavior. That is a very important question which is not addressed by our code.
Actually, it's one level up. India has not reached this level, which is there in the concept of limited ductility. But yes, we've heard of it. But how really we tackle, we'll take some time to reach there. Right now, we're only learning ductility. Okay, so next one is from Biplab Kanti Som. In Japan, what type of bearings are used? Japan is a high seismic zone, so maybe that is a context.
Zone. They use mostly for not too tall building, they use lead rubber bearings.
Right.
Sliding pendulum for the moment is not used. You must understand that Japan is a very close market where the local manufacturer make the rules, and for a foreign company is very difficult to enter. So for the moment, they developed only high damping rubber bearings and lead rubber bearings, and not the pendulum.
Right.
But Agustino, in the very tall buildings, they're using TMDs. They're using
TMDs, yeah.
TMD, but yes. But TMD is mainly used for reducing the wind-induced vibrations. Okay. And TMD has limited effect also in reducing the deflection due to the earthquake.
I know they believe a lot in rubber bearings and high damping, no doubt. Another interesting question is, as discussed regarding elastomeric bearing, what is the general ratio of horizontal to vertical force?
I think that is given in the, like this quotes, like there's a criteria to satisfy this, shear modulus. Actually, that has to be seen basically.
Right.
Yeah.
Can be estimated very easily.
Yes.
But in any way, the horizontal force in a rubber isolator is equal to so you have to make to consider the stiffness of the rubber, the shear modulus of the rubber multiplied by 2.
Correct.
And for the vertical load, you can have the shear modulus of the rubber multiplied by 5. So you may have the ratio between the horizontal and the vertical around the 20%, 20-30%.
Right.
Anyway, the rubber isolator are fixed to the structure not by friction, but by mechanical, by bolts, by dowels.
Yes.
So not by friction.
That is how Dr. Harshavardhan has been done in this Dwarka Expressway also.
Yeah.
Mechanical connections.
Okay.
So I think we'll have to shut this here now. And sorry, I'm curtailing a few things because we didn't want to overshoot the time, and we have overshot by half an hour. If need be, we'll have one more similar discussion forum on the same topic some other time, so that I know a lot of things are still unanswered, unspoken, not discussed yet properly, and all that. I'll request see, we have two backbones of this organization, IIB. One is Engineer Swapnil Joshi, who runs a company wherein they deal with the project management aspects of various large projects, who I think spoke some time back. The other very important person and really a backbone is Dr. Gopal Rai, who's more into retrofitting. So when you don't want to waste a structure, you can contact him, and he'll give you a solution to save your structure. So Dr. Gopal Rai, he's honorary secretary at the same time. I'll request you to please propose a vote of thanks.
नमस्ते सर, थैंक यू वेरी मच सर। सिर्फ एक सवाल और एक थ्रू आउट डिस्कशन आई see and we are doing major rehabilitation of bridges. One request to all the consultant and client for bearing, especially we should have a bearing replacement manual for each and every bridges, and we should always plan for bearing replacement system for every bridges, because when I go for rehabilitation, sometimes the bridges are not like the jacks are not possible to put in the for the replacement and all. So I request that all the committee and all the expert, we should try to post for every bridges there should be bearing replacement manuals. Okay, so that in future for rehabilitation it should be done properly. So with this small note, thank you very much, sir. And let me conclude and let me give my vote of thanks. Let me thanks today's the speaker, Dr. Agustino Marioni. Thank you very much from Italy. Live he was there, and really he has a passion for bearing. Okay, so we can see from, and he can talk for number of hours, kind of experience he has and expertise he has in the field of bearing. And let me thanks to our panelists today, Dr. Harshvardhan Subbarao, Engineer V.N. Hegdeji, and Engineer Atul Bhobeji. Thank you very much for guiding us and helping the panel discussion on the live mode. And let me thanks to our today's moderator, the best moderator, and who has really from last 2.5 hours, we are making a discussion. Still the crowd is there, and still they are eager to wait for the discussion and all. But looking at the constraint on the virtual platform, we cannot stretch much. But in future, we'll continue for the discussion. Thank you very much, Engineer Vinay Gupta ji, our president for IIB, for conducting the this panel discussion, and really the kind of registration and kind of response we are getting, and it is just like a manthan of all the subjects. And thanks to Dr. Harshvardhan Subbarao for suggesting such a panel discussion and all. Let me thanks to our Director General, Engineer Devteji, for joining us and enlightening us. Let me thanks to Engineer Goyalji for helping us in the discussion from the one of the largest bridge forum, or we can say bridge engineers, Indian Railway. Thanks to today's sponsor from SICO and Hairun for sponsoring today's talk. And let me thanks to our all the panelists, and especially to Engineer S.K. Puri Sahab for giving a valuable time for the complete discussion and for the today's subject. Last but not the least, my colleague Engineer Swapnil Joshi for giving a valuable time and suggestions. And especially thanks to Deepika Singh, Engineer Deepika Singh, from beginning the talk, and to Advocate Ruhi Agrawal for coordinating overall this open talk, and Huzefa, who is the IT man, who helped us in all doing this discussion. And finally, thanks to all the participants who really from close to more than 200 people have participated from the beginning, and still people are there. Thank you very much. Keep joining, and we will wait for the next talk. It is the annex of what we have in the May month we have done on Chenab Bridge. Again, we are calling the same speaker, and with the new thought and new ideas. So over to you, Jai Hind.
And my sincere thanks to the sponsor, Hirun Seko, who have made this happen. And my thanks to Dr. Gopal Rai, who's always been spearheading this entire IB with all the energy and enthusiasm. He never loses enthusiasm. He never loses his energy. Thank you. Thank you, everybody. Thank you so much.
Thank you. सभी को इंडिपेंडेंस डे की 75वीं वर्षगांठ की शुभकामनाएं. हैप्पी इंडिपेंडेंस डे इन एडवांस. थैंक यू वेरी मच सर.
Thank you, Dr. Roy.
Thank you.
Thank you.
Thank you. Thank you all.
Thank you. Thank you all.
Thank you.